All right, so I'm just setting up a couple of numbers here to do an example problem, well, with numbers. So let's say we have a 3 kilogram mass and this inclined plane is 30 degrees. And again, so M here, this is 3 kilograms. And we got two goals. We want to find the normal force and we want to find the acceleration of the block. So I'm going to go ahead and do that now using this technique that we talked about in class. So here's the weight on the free body diagram, and here's the normal force. And again, the way our x and y axes work, they're tilted so that this is the y and this is the x. And the way we set up our equations is we're going to have w cosine, we're going to have, set this up properly, w sine of, and the angle is 90 minus theta. And here it's w cosine of 90 minus theta. So the way this works is like this. In the y direction, we're going to set up our equations, and that means the normal is going to balance mg, which is the weight, times the sine of 90 minus theta. Now let's plug in our numbers for that. We're going to get n equals 3 times 9.8, which is the acceleration due to gravity, times the sine of 90 minus 30. Whoops, running out of space there. And so when I do this math, this is actually going to work out to the normal force is 3 times 9.8 times the sine of 60. And that's going to actually work out to about 25.5 newtons. And in the x direction, well, that's actually one of the things we wanted to find. In the x direction, we're going to actually set up the second law, or Newton's second law, which says the sum of the forces is the mass times the acceleration when the forces are unbalanced. And in this case, that's w times the cosine of 90 minus theta equals ma. And so that's going to be mg times the cosine of 60 equals ma. We're going to plug in numbers, so 3 times 9.8 times the cosine of 60 equals 3 times the acceleration. We can divide through by 3 on both sides, and when we actually solve, we're going to get an acceleration of 4.9 meters per second squared. So this is very basic practice. For your problem on the Google Doc, I'm going to actually have you practice this with a coefficient of friction.